Hello, cosmic enthusiasts and curious minds alike. Today, we're venturing deep into the mysteries of the cosmos to explore the top 6 unexplained space signals just detected. These signals have baffled scientists and sparked a myriad of theories about what or who might be sending them from the far reaches of space. Grab your telescopes and let's dive into these cosmic conundrums. Until now, we hadn't been able to detect neutron stars emitting radio waves from other galaxies because they simply weren't energetic or bright enough. But for the first time, we might have spotted a neutron star from an incredible distance. Mysterious radio wave pulses from deep space have been reaching Earth for decades, yet their origins remain a puzzle. What are these signals, and what causes the odd, sometimes clockwork-like pulses? Could these signals be a form of advanced communication beyond human comprehension? Here are 6 unexplained space signals that have left scientists scratching their heads. Number 1, GPM-J 1839-10, a team of astronomers at Curtin University, part of the International Center for Radio Astronomy Research, has uncovered strange, regular blasts of energy. These blasts have been firing every 20 minutes like clockwork for the past 35 years, astonishing, right? Published in the prestigious journal Nature, their discovery of the signal, named GPM-J 1839-10, reveals a pattern of activity previously thought impossible. Dr. Natasha Hulley-Walker, the lead researcher, described this remarkable object as a discovery that challenges our understanding of the universe. Our understanding of neutron stars and magnetars, some of the most mysterious and extreme objects in the cosmos, has been deeply challenged. It all started back in 2018 when Natasha's team noticed a magnetar spinning unusually slowly, emitting signals every 18 minutes. However, by the time they analyzed the data in 2020, the magnetar had mysteriously ceased its radio wave emissions, abruptly halting their research. Undeterred, the team was confident they could identify another persistent radio source. Using the Murchison Wide Field Array radio telescope in Western Australia, they scanned the Milky Way galaxy every 3 nights for several months. They didn't have to wait long. A new source emerged in a different part of the sky, repeating every 22 minutes with 5-minute pulses. The discovery seemed too good to be true. When they cross-referenced with records at the Very Large Array in New Mexico, which boasts the longest-running data archive, they were astounded. This same source had first been detected in 1988, nearly 35 years ago. For over 3 decades, a baffling signal has eluded explanation, leaving scientists scratching their heads. Despite their best efforts, they've yet to pin down where these signals originate or what's behind them. Could it be that extraterrestrials have been trying to contact us, and we've just been too clueless to notice? It's a tantalizing thought, but scientists are exploring more grounded theories. The most probable explanation points to a pulsar, a type of neutron star that acts much like a cosmic lighthouse, emitting beams of energy as it spins. These pulsars gradually slow down, their pulses dimming with age until they eventually cease. But here's a twist: the source of our mysterious signal is a pulsar spinning 1,000 times slower than the norm. Another intriguing possibility is that we're dealing with an ultra-long-period magnetar. These are rare neutron stars, known for their intense magnetic fields and the powerful energy bursts they can unleash. But the true nature of our enigmatic signal remains shrouded in mystery. And there's more: another unexplained cosmic event. On June 10, 2022, astronomers caught an intense signal they've dubbed FB 20226Y1A. What's the story behind this newfound signal? That remains part of the unfolding mystery of our universe. Imagine a signal traveling 8 billion light-years through the cosmos to reach Earth. That's exactly what happened with the Fast Radio Burst, FRB, named 2020610A. This intense burst lasted less than a millisecond, yet it was 4 times more powerful than any FRB previously detected. To put it into perspective, the energy released in that fleeting moment was equivalent to what our Sun emits over 30 years. FRBs are among the most mysterious phenomena in the universe, brief but incredibly intense bursts of radio waves originating from deep space. Although they typically last just a few milliseconds, they pack as much energy as the sun does in an entire day. The true nature of FRBs remains elusive, with scientists proposing various sources, such as neutron stars, black holes, and even exotic objects like magnetars. Since the first FRB was discovered in 2007, hundreds more have been detected, some of which repeat. The fact that these signals travel billions of light-years and still carry such immense power makes them a captivating subject in astrophysics. However, because they vanish almost as quickly as they appear, observing them closely is a formidable challenge. Fortunately, radio telescopes have been invaluable in tracking the paths of these quick cosmic bursts, offering glimpses into the mysteries of the universe. When it comes to unraveling cosmic mysteries, the Australian Square Kilometre Array Pathfinder, ASCAP, and the European Southern Observatory's Very Large Telescope are at the forefront. When scientists detected the radio burst 202020620A, it led them to a massive celestial object that initially appeared to be a single irregular galaxy or possibly three galaxies interacting. But recent observations have revealed something far more intriguing. Thanks to images from the Hubble Space Telescope, astronomers have determined that the fast radio burst originated from a cluster of at least 7 galaxies. These galaxies are so tightly packed that they could all fit within the Milky Way. The galaxies seem to be interacting closely, perhaps even merging, and this cosmic dance might be the very trigger behind the fast radio burst. This cluster, known as a compact group, is one of the densest galaxy-scale structures we've ever discovered. As study co-author and Northwestern University Associate Professor of Physics and Astronomy, Wenfei Fang, suggests, these interactions might ignite bursts of star formation, potentially linked to the observed radio burst. Most FRBs have been traced back to distant galaxies, but this discovery highlights the possibility that these powerful signals could emerge from densely packed galactic neighborhoods where stars are being born at an extraordinary rate. Most fast radio bursts have been traced back to isolated galaxies, and some have even been linked to globular clusters. But now, astronomers have discovered one originating from a compact group of galaxies, making it truly one of a kind. Next up, number 3, ASCAP J135+2148. On Earth, astronomers frequently detect bursts of radio waves, known as radio transients. Some appear once, never to be seen again, while others flicker on and off in predictable patterns. Most radio transients are believed to come from rotating neutron stars, known as pulsars, which emit regular flashes of radio waves like cosmic lighthouses. These neutron stars spin at incredible speeds, completing each rotation in mere seconds, or even fractions of a second. However, researchers have recently encountered a radio transient unlike anything they've seen before. This phenomenon not only has an unusually long cycle, nearly an hour, the longest ever recorded, but it also alternates between emitting intense bright flashes and rapid faint pulses. Meet ASCAP J135+2148, a radio transient discovered by the CSIRO's ASCAP radio telescope in Wajari Yamaji country, Western Australia. The telescope's wide field of view played a crucial role in spotting this extraordinary signal, revealing a whole new chapter in the study of cosmic radio waves. The ASCAP telescope is a powerful tool, capable of surveying vast regions of the universe with incredible speed, making it ideal for discovering new and exotic phenomena. While using ASCAP to simultaneously monitor a gamma-ray source and search for fast radio bursts, the team stumbled upon ASCAP J1935+2148, a signal that stood out from the rest due to its slow, steady flashes. What made this signal particularly intriguing was its circularly polarized radio waves, meaning the waves twist in a corkscrew pattern as they travel through space. While human eyes can't distinguish circularly polarized light from ordinary light, ASCAP functions like a pair of Polaroid sunglasses, filtering out the glare from thousands of ordinary sources to reveal something truly unique. After this initial detection, the team conducted further observations over several months using both ASCAP and the more sensitive Meerkat radio telescope in South Africa. While radio signals from space are nothing new to astronomers, this one belongs to a relatively new class of long-period radio transients. But this discovery is just the beginning. The scientists believe ASCAP J 1935 plus 2148 could exhibit 3 distinct states, and they've only begun to observe its exceptionally long period. As they continue to study this fascinating signal, it may unlock even more secrets about the universe. In the first state, we observe bright, linearly polarized pulses that last anywhere from 10 to 50 seconds. In the second state, the pulses are much weaker, circularly polarized, and last only about 370 milliseconds. The third state is a quiet or quenched state, where no pulses are detected at all. One possible explanation for these different states could be the complex interplay of magnetic fields and plasma flows from the source, influenced by the strong magnetic fields in the surrounding space. To put this into perspective, astronomers have seen similar patterns in neutron stars, but our current understanding suggests neutron stars shouldn't be able to produce such a long period. So, where is this exceptionally long signal coming from, and what does it mean for our understanding of the universe? Could it be caused by a slowly spinning neutron star, or might it originate from a white dwarf, a burnt-out star that has exhausted its fuel? That's the mystery astronomers are still trying to solve. Moving on to number 4, in 2023, astronomers using the James Webb Space Telescope made a groundbreaking discovery: unusual free-floating planetary mass objects in the Orion Nebula. This finding challenges our understanding of. Voyager 1 was the pioneer in exploring Jupiter's realm, but Voyager 2 followed closely, not only confirming many of its predecessors' discoveries but also unveiling new ones. Voyager 2 was strategically directed to fly closer to several of Jupiter's moons, Ganymede, Callisto, Io, and Europa, to maximize its scientific yield. These moons, Jupiter's largest and visible from Earth with just a backyard telescope, were prime targets for observation. As Voyager 1 looked back at Jupiter, it made a surprising discovery: a thin ring encircling the mass coming from some of the so-called Jupiter mass binary objects, or jumbos. But what really caught their attention was that, out of 40 identified pairs of these jumbos, only one was found emitting radio waves. Jupiter mass binary objects, or jumbos, are pairs of astronomical objects, each with a mass similar to that of Jupiter, orbiting one another. Unlike typical star systems, these objects aren't massive enough to trigger nuclear fusion and become stars. Instead, they remain substellar objects, possibly brown dwarfs or large gas giant planets. Because they never ignite the process that defines a star's life, brown dwarfs with masses between 13 to 75 times that of Jupiter have earned the unfortunate nickname, failed stars. Jumbos are particularly fascinating because they challenge traditional ideas about how planets and star systems form. They might form in isolation, like stars, but fail to accumulate enough mass to ignite fusion. Alternatively, they could be ejected from forming planetary systems and later pair up as binaries. This discovery is reshaping our understanding of the cosmic processes that give birth to celestial bodies. According to Luis F. Rodriguez from the National Autonomous University of Mexico, even with our current star and planet formation models, it's challenging to explain the existence of jumbos. Now, with the discovery of strong radio emissions coming from these objects, the mystery deepens. The radio signal was detected from both components of Jumbo 24, which are quite similar in size, each with 11 times the mass of Jupiter, making them the largest of their kind observed by the JWST. Other identified jumbos range from 3 to 8 times the size of our solar system's most massive planet. Scientists are still trying to figure out how jumbos fit into the existing star formation models. What makes this discovery even more puzzling are the unusually strong radio signals coming from these objects, signals far more intense than anything previously observed from similar objects like brown dwarfs. While scientists have explanations for radio emissions from regular stars and brown dwarfs, they have no clear mechanism to account for these powerful emissions from jumbos. Jumbos, hot and gassy objects smaller than typical stars, defy expectations by existing in binary pairs, a rarity for objects of such low mass. Usually, only the most massive stars form binary systems, making the existence of jumbos even more intriguing and mysterious. While massive stars often form in binary pairs, smaller stellar bodies like brown dwarfs rarely do. This anomaly presents a significant challenge to current star formation models, which struggle to explain why so many jumbos have been discovered in the Orion Nebula. Given their weak gravitational bonds, these jumbos should have been easily disrupted if they were ejected like rogue planets. Yet, the presence of 42 such pairs in Orion suggests that jumbos are not the result of a rare, isolated event, making their formation even more mysterious. Could these signals be signs of life on jumbos? Scientists don't think so. According to Luis F. Rodriguez, life isn't expected on Jupiter-like objects without a solid surface. Jumbos are supposed to be much cooler, as they aren't associated with stars, making them inhospitable to life. Even if jumbos had moons, the chance of life thriving there, similar to what we suspect might exist in the subsurface oceans of Europa, Ganymede, or Enceladus, seems slim. The objects in Orion are relatively young, only a few million years old compared to our 4.6 billion-year-old solar system, so there likely hasn't been enough time for life to develop, even if moons exist. Our first signal, detected by the SETI, Search for Extraterrestrial Intelligence, project, originates from a region in the sky with no visible stars within 1,000 light-years. This signal has been observed 3 times, each time only adding to its mystery. The consistency and frequency of SHGB02+14a suggests something beyond random cosmic noise, yet the lack of a clear source keeps scientists guessing. Perhaps the most famous unexplained signal, the WOW signal, was a strong radio signal detected by Dr. Jerry R. Eman in 1977. Lasting a full 72 seconds, it bore the expected hallmarks of extraterrestrial origin but has never been detected again despite numerous attempts. The debate continues: was it a message from distant intelligent life or a transient astronomical phenomenon? Fast radio bursts are intense bursts of radio waves from space that last only a few milliseconds. Their origins are completely unknown, though theories range from merging neutron stars to alien communications. What makes FRBs particularly intriguing is their enormous energy output, suggesting a phenomenon of incredible power. Once thought to be signals from outer space, peritons turned out to be a more mundane, yet still intriguing source: microwave ovens used by astronomers during their lunch breaks. This humorous twist reminds us of the challenges in distinguishing earthly interference from genuine cosmic signals. Unlike other FRBs, FRB 121102 is known for repeating itself, emitting bursts that have been traced back to a small dwarf galaxy over 3 billion light-years away. Its repetitive nature provides a unique opportunity to study these mysterious bursts and perhaps understand the forces driving them. In 2014, the Rosetta spacecraft recorded a mysterious song emitted by Comet 67P/Churyumov-Gerasimenko. This eerie melody was produced not by sound waves, but by oscillations in the magnetic field in the comet's environment. Scientists study these vibrations to learn more about the comet's structure and its journey through space. Detected by a telescope in Puerto Rico, this signal emanated from a point in space with previously recorded unexplained activity. The signal's pattern suggested an artificial origin, yet no further evidence has supported this theory, leaving its nature and origin as yet another cosmic puzzle. From the center of our Milky Way galaxy emanate powerful radio waves that have defied clear explanation. These signals could originate from a black hole or other massive astronomical structures, but their specific characteristics sometimes mimic those expected from artificial sources. Some stars exhibit unusual light fluctuations that cannot be fully explained by known natural phenomena like star spots or planetary transits. These anomalies have led some to speculate about the presence of megastructures built around stars by advanced civilizations. Signals that appear redshifted beyond what is expected from cosmic expansion suggest they come from the very edges of the visible universe or perhaps beyond. These signals challenge our understanding of the universe's structure and the laws of physics as we know them.
Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.